So let's continue with the third question from yesterday's video. Basketball competition is held when number of players does not have maximum or minimum limit. There are any candidate players in the competition that will be trained. The best basketball, the Ithnes Power IPI, form 0 more teams for men candidate players on condition that each candidate player may only join in at most one team. Each of these teams will be sent to compete once with the enemy team that has power of D. In each match, the team is said to defeat the enemy team if sum of powers of the form player is strictly greater than T. So in this trainer skill is that when the team that has been formed plays in a match, he can change the power of each player in the team to be equal to biggest power from the team to find the maximum number of wins that can be achieved by Park Chan-ek. Number of candidate players and power of enemy team, power of all candidate players, and then line containing integer number of wins. Okay. The first thing what did he do was first thing formed is a team containing player 4 and 6. 1, 2, 3, 4 and 6. Power of each player in the teams becomes 100. So the total power is 100 plus 100, 200 greater than 180. Okay. Second team is formed by players 1, 2 and 5. The power of each player becomes 90. Total power is 90, 90, 270 which is 180. Fine. Hmm. So the values which we have are 90, 80, 70, 60, 50 and then 100. Now the first team which is formed is containing player 4 and 6. This is 1, 2, 3, 4, 5 and 6. So with 60 and 100 we formed one team and the another team is using player 1, 2 and 5. 90, 80 and 50. So what did he do was he just trained this guy with 100 so that we got 100 here and the three players here with 90, 90. That's the skill which is mentioned over here. He can change the power of each player in the team to equal to biggest player from the biggest player power from the team. If we select 1, 2, 4 and 6 and 5 then we will be left with a 70. I think we cannot form a team with this person. What about uh, look for another, like there might be some other way also for selecting those teams. If I'll just sort the array 50, 60, 70, 80, 90, 100 and then 190, 180 by 100. If I look for the ceiling of this thing, which is 2, so I can select minimum, I have to select minimum 2 players if I take 100. So I'll just add a 2 here and then I'll decrement the length of the string by this number 2 and I'll be remaining with 4. Now we have 90. Now 180 by 90, which is again a 2. So I'll just select two players for this, and then my length will further decrease. I'll be left with more two players to select. Now if I go with 80, 180 by 80. So it's not possible, I guess. 180 by 80 ceiling of this is 4 twos, 2 fours, 2 nines. 9 by 4 is somewhat equals to 3. But I guess we don't have 3 players, we have only 2 players left. So we cannot go for this. Hence, we have to go with these two. Therefore, we have only two ways of winning. I think that's how we have to work out the solution for this problem. Int d, in the damage, and int of score equals to 0. Then I'll just select a temporary variable int equals to n, I comma n, and then I'll make an array of n variables. Now the next step is I have to sort it first. I'll be using the inbuilt sort function. I have to iterate in the reverse manner. Hmm. So the place where my code is failing is this thing. The power has to be strictly get. And I have to create another variable. Strength equals to 0. Then the strength will be assigned as the CS into CS means amount of people which I have into AI. If the strength is greater than D, then I'll add 1. And well, this might work now. What was the test case? 2 comma 4 1 comma 2 0. Well, that's good. Let's just try submitting it now. Yeah, I failed. I clicked Control V 2 times. Wrong answer on test 23. First numbers differ, expected 5000, found 0. Then I think this approach is not the correct thing to go for. Number of players in team does not have maximum or minimum, not considered and candidate players in competition. Okay. We need how many ways we can train the data for. We just go for implementing it like this 180 by 100. Ceiling of this from here we'll get two numbers plus 180 by 90. From here we get how many? 9. We get 2 again. Now 180 by 80. 4, 2, 2, 4 are 8, 2 9s are 4 by 9 is, I think ceiling will give me 3. So this 4 plus 3 is exceeding 7. To simply go with 1 plus 1. If I create a custom test case like 110, this is 5, 5, 5, 5, etc. Now 10 by 5 is 2 plus again 10 by 5 is, I mean, yeah, 10 by 5 is 2. So in two ways he can defeat. Either he can choose this one, or this one and this one. Or else he can choose even this one and this one. Hmm. That's the twist here. Maximum number of wins that can be achieved. He's asking maximum number of wins. He's not asking in how many ways we can defeat. So if I have selected those two files first, then I have to select the other two files. And any means I have to. It's compulsory for me to select these one. I mean, there is no other. I mean, he's not asking the amount number of ways to defeat him, but he's asking how many wins we can do. If I go with the earlier example, mm, sorry, I mean 1 comma 2, and we get 2 comma 4 here. 4 by 2 is 2. I mean, here also we cannot defeat exactly in with 2 people. We need 3 people here. So if 10 modulo 5 n modulo ai not equals 0, let's say, I mean equals 0. If it's not equals to 0, then we just have to add a number plus 1 and subtract it to the n. t minus cs is greater than 0. Then I'll add a 1 to the score. Failure. 100. 180 by 100 is somewhat 2. Else, I guess VS Code crashed. Now let's try it. I'll add 1 and t minus cs, and I'll add a if condition here. Now let's try it. Failed. 100. If 180 modulo 100 equals to 0, no, that doesn't happen. Or else, no, I think we don't need to do cs plus plus here. If t minus cs 3, 6 minus 3 is greater than 0. Okay, it's passed. Now let's try submitting it. Wrong answer on test 6. It's a simple problem, like only we need to do some, not even brute force, but like 1, 2, 3, 4, 5, 6. 100 into 2, this is one thing, or 90 into 3. This is one option. Or else 100 into 3 and 90 into 3 can also work, but this is also fine. So D is 180, and 180 by 100 is around 2. CS will be 2. If CS into AI greater than D, what about the case 1, comma 2 and 3? One comma 2. Now if I go according to this, D is 3. 3 by 2. We just need 2 people. 2 people are sufficient. CS into AI is greater than D. Then what we can do is just I'll add 1 to the score, and then I'll subtract D with CS, and the same thing I'll apply here as well. Oh, if I submit it, I'll just look on the test cases which I got failed before. 2 comma 3, 1 comma 2. Oh, it's 0 again. N and D, and the array is sorted. Then 3 by 2, ceiling of 3 by 2 is 2. Else if CS is no, CS will be 2. 2 into 2 is 4. 4 is greater than D. And T minus CS. 2 minus. Okay, okay. Just put this condition. I think we don't need this here. Oh, we'll just try running on the test case. 2, 3, 1, 2, 1. Okay. And if I try another test case, 2, 4, 1, 2, 0. Well, that's good. Now I'll try submitting it. Finally, got accepted. Okay, it was an easy problem actually. It took me time, but just it was somewhat finding how many people have some good amount of strength so that they can dominate that. First thing I did was I sorted the array in reverse manner. I mean, I sorted and I iterated in reverse manner. Then I looked for the strengths. This thing was not required anyhow. What I did was I found out how many people of that same strength are required if for defeating this monster. So I took the ceiling function for that. Now, if it was divisible by this, then I added a 1 to this thing, or else I just continued with the ceiling thing. And then if this was sufficient to defeat the monster, and also if I use that amount of members for defeating the opponent team. I mean, I should not run out of members, so that's why I put this condition. And I incremented the score and I subtracted from this. Else, the same thing I did, but I didn't increment here because it was not needed. Or else, if I didn't increment, the strength will be equal. It will not obey the strictly greater condition. And then just try implementing this code yourself. It took me some time, but it was an easy question, around half an hour. Now we'll move to the second beautiful array. Stanley defines beauty of array which contain non-negative integer as follows. Which contains as follows, which means that when that we divide each element by k, round it down and sum up resulting values. Sam and integer k and ask him to find array A of n non-negative integers such that the beauty is equal to b, and this is the beauty of array. Okay. Then find array b and the sum of elements. Okay. Contains the description of test cases, and then we have nkbs sum of n print minus 1 does not exist, otherwise print n non-negative integers. Okay, fine. And these are the test cases. Example, it's possible to show that such array does not exist. Well, and if you go for this thing, first of all, let me just write what the question is asking. If I organize things, that might be more better for me. The tip or what else, the suggestion while solving problems is try organizing things in your brain rather than using pen and paper. So first I'll try organizing things in my brain, then I'll go for doing it on pen and paper, so that you will improve your thinking, and it just fastens your it will increase the speed of thinking. You'll just start thinking fastly. Stanley defines beauty array of a length and which non-negative integers. Each element divided by k rounded down the sum of the resulting values. And it asks him to find array of non-negative integers so that beauty is equal to b. A of a beauty is equal to b, and the sum of element equals to s. There is some formula for ceiling, I guess. Ceiling formula. There's a direct formula which will make our work more easier. Yeah, this thing. A plus b minus 1 divided by b. I'll just note it down. Hmm. Now we are good to go. The sum should add up to b, and then also the sum of elements should be equal to s. Now sigma I equals to 1 to n is equal to s, and also sigma I equals to 1 to n ai plus k minus 1 divided by k should also be equal to, it should be equal to b. Now we have to just break down the things. Ai sigma I equals to 1 to n. I'll take 1 by k outside, plus sigma I equals to 1 to n k minus sigma I equals to 1 to n 1, or else just k minus 1 equals to b. Now which equals to 1 by k. Sigma ai is s plus I the sum of 1 to n k minus 1, it just n times, like k minus 1 plus k minus 1, so it will be into n, I guess. Sigma equals to 1 to n 1. What is this? And just forget trivial things. 1 plus 1 plus up to n, it's nothing but n. Well, fine. Hmm. So this is the condition which should be obeyed. S plus n into k minus 1 equals to b into k. And printing the array is a quite simple thing. Just once we find out what are the requirements. These are the requirements to take place. What is b? The beauty of array. Now the given constraints are n, k, bs. We are given with everything here. I'll just break down the condition. I'll write it somewhat neatly. Hmm. Now I'll just copy paste it and write it here. S plus b into k. That's it. Now we are good to go with the remaining things. Hmm. Now we have n, k, b, and s. In the first test case, if we verify 1, 6, 300, which is n, k, b, and s. If I try implementing as 100 plus 6, I mean 3 into 100 s plus n, 1 into k minus 1, 5 equals to b into k. Even if it's greater than or equal to, I guess it will be fine for me. What is b into k? B is 3 into 6, 18. No, it should not be greater than. Hence, it's not possible to print the array. If I go with the third test case, where we have 3, 6, 3, and 19, because there exists a solution for the third test case. NKBS 19 plus 3 into 5 equals to b into k. 3, 6 are 18. Beauty is equal to b and the sum of elements is equal to s. So things should be exactly followed. S, B, NKBS, NKBS, S is 19 plus N is 3, K minus 1 is 5 is equal to B. B is 3 and NKB into K 18. 19 plus 15 is equal to 18. Beauty is B, and if I do 19 by 6, we'll be getting 3 here. Okay, okay. 5, 4, 7, 38. N, K, B, and S. Hmm. The sum should add up to 38 and beauty should be 7. And K is 4. 38 by 4 is equal to 38 by 4 is somewhat, if I take the floor of it, 4, 9, 36, it will be 9. So B cannot be 9. Uh, it should be less actually. Matlab, I mean 38 as divided by K. This thing should be less, I mean greater than or equal to whatever the value which we have to find, which is, I mean the beauty which we require is B. That's the condition. Then only we can clear the array. If you look at this test case, 163 nkbs, 100 divided by 6, floor of this, and beauty is 3. 236, 2 into 50, and then 3 ones 3, 16, it will be 16, 16 greater than or equal to 3. Mm. Or else I made some mistake in the derivation. I divided by k, summation I equal to 1 to n is equal to b, and summation I equals to 1 to n ai is equal to s. I think that is CL. I used the wrong formula. I needed the formula for floor, not CL. These are the both conditions. Floor of A by B. For ceiling, we had A plus B minus 1 divided by B gives the ceiling value. What we need is floor of A by B. AI divided by K. Sigma equals to 1 to N. I need to take help of some inequalities here. You know that, wait, sigma I equals to 1 to N AI by K is greater than or equal to sigma I equals to 1 to N floor of AI by K. Okay, now if we break down this thing, then we'll get as S by K is greater than or equal to B. This is the condition. So B into K should be greater than or equal to S. Now we check the first test case. We have 1, 6, 3 and 100, N, K, B and S. B into K is 18. 18 is not greater than 100. That's why the test case failed. I mean, we don't get an answer here. Now if we check for the third test case, 3, 6, 3, 19, N, K, B, S. B into K is 18 and S is 19. It's somewhat near, but or else if we go for this equality instead, inequality, 19 by 6 is greater than or equal to 3. If we apply this, it's 3, 3 is greater than or equal to 3. This might work better. 1, 6, 300. Also, the thing that matters here is the value of n also matters here. It says 100 and that's fine, but the thing is, what about n? N also plays a role here. We check for this test case. One, two, four, fifth test case. 5, 4, 7, 80. 4, 7, 80. Now n k b s 80 divided by 4, or else b into k, let's say 28. That's all equal to 80. This condition is always being followed here. You can also select 0 here. NKBS. This is the beauty of the array. If I do 19 by 3, floor of 19 by 3 gives me 6, which is equal to k. What about the test case? If we go for the fourth test case, let's say 5, 4, 7, 38. 38 NKBS 38 divided by 4, it is somewhat equals to 9. 9 is greater than 7. This will exist but similarly if I go for 5, 4, 7, 80. 80 by 4 is also 20. It's greater than the thing. 38 by 4 is 9. And we need the beauty to be 7. It's possible to achieve the beauty. What can I do is 38 by, just make it divisible by 38. I mean by 7. 28 by 4 equals to 7. So the number 1 I'll be adding is 28. And I'll be left with another 10 value. And I have 5 places to fill. 3, 4, 5. What can I do is I just want to make them 0, 0, 0. I mean here 0, here 0, here 0, and here 0. How can I do that? Before, if I fill with 3, 3, 3, 9, and 1, yes, that's the most appropriate answer which I can get. I need beauty to be 7. So I'll do it 7 into 4 as 28. Or else 7 into 5, 35. 35 minus 1. What will get is 34. 34 divided by 4. 4, 7 are 28. Yeah, I'll get 7, bro. So B into K plus 1. And the remaining numbers, they should be distributed. 17 to 5. Also the B into K plus 1 should be less than or equal to S. Just similar to the earlier condition derived. This thing also should be followed here. Even if it is minus 1, then also it's okay. B into K plus 1 minus 1 should be less than or equal to S. This is one thing. 7, as we can see, 7 into 5 is 35, 35 minus 1 is 34. And then we'll just decrement 10 by 1. We'll be having n minus 1. Then S minus B into K plus 1 minus 1. Whatever the value I get, suppose 38, 38 minus 35, 34, if I do, I get 4. No, 4 divided by 4 equals to 1. I have to distribute the 4 in this 4 places so that the ground of their sum is equals to 0 totally overall. How to do that? The number should not exceed 4 actually. Means suppose I had 16. So then 16 by 4 will be 16 by 4 will not be acceptable because if I divide it into 4 parts. N minus 1, n minus 1 into k. What is n minus 1 into k? Minus 1. N is 5. N minus 1 is 4. 4 into k. K is given as 4. Suppose if I was left with 5, let's say, then also with each digit appointed as 1, the work would be. Hmm. I somehow managed to print this, but how do I print this? I have 4 left now, and 4 by 4 is 1. I cannot print that. I need to split it. I need to split the 4 into 3 and 1, so that then only I will be able to print them. The main thing is splitting those remaining numbers. That's what we are concerned about. After that, remaining the problem is nearly solved. Let's say we have 3, 6, 3, 19. What I can do is 3 into 7 is 27 minus 1. No, 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 no. This problem is somewhat difficult. It's based on maths. Yes. This is 19. If 19 divided by k is less than or equal to b, k is 6. But what if it was 2? If it was equal, then that will be fine. And if it was greater, then also it will be fine. But if s divided by k less than or equal to b, then I will simply print a no. As we have done in this second test case, if we see 12 divided by 6 is 2, which is less than or equal to 3, I'll just print it no. If we look for the, I mean less than, if we look for the opposite test case, then what I'll do is, first of all, I'll print k into b. K into b is 18 here. Then I'll print the remaining number as I will subtract k into b from s. Now my aim is to split and print those numbers. How will I be split? How will I split them is I have 1 with me. 1 divided by 6 equals to 0. Then I'll just print 1 here. This will be definitely less than this thing for sure. But suppose if I had some number like 7, I don't think there will be some possibility for getting a number 7. If I go with 0, 3, 3, 333 and 29 and then k, no, sorry, that was different. See, I'm done with the printing thing, but just I need to decide how to split these numbers. Let's say I have 5, 4, 7, 38. Then first of all, I'm printing 28 here. Then S will become 38 minus 28, which is 10. And KBS 10 by 4 is 2. Then what I'll do is 10 divided by 4, which is 2. I have 5. I have 4 indices remaining with me. 4 is K here. Mm, I'll be just printing 4, 4, but that's not possible. If I print 4, then my answer will become, the beauty will get destroyed. Whether I can print 3 or 2 mostly. 10 divided by n minus 1, which is 2. So if I print 2, 2 here. But what is the guarantee that if I divide this with 4, 10 divided by n minus 1 divided by 4 should always have a seal equals to 0. I think that I don't need to worry about that condition. 2, 2, 2, 2, 3, 6. If I do this, okay. 10 divided by 4, the ceiling of it is 3. It's a difficult problem. Till now it's fine, but now I have problem with the splitting of numbers. If it is greater than k, then definitely. If it is greater than or equal to k, then definitely I'll print minus 1. Here's the main problem. Hmm, I'll be swing the model and I'll set the flag equals to 1. If the flag exists, then It's a bit quite confusing. Let's just look at the editorial. I'll be back in a minute. Now let's try using some hints here. First of all, it's a greedy algorithm. Okay, that's fine. What are limits on S with all else being the same? Now what we have is, okay, let's just derive it again. Beauty is known as sigma I equals to 1 to n ai divided by k, and summation is sigma I equals to 1 to n ai. Now this thing is always, beauty is always less than or equal to sigma I equals to 1 to n ai divided by k, because it's the floor function, and then b is always less than or equal to s by k, which implies s is greater than or equal to b into k. This is the, I mean, what we can say, this is one bound on s. We'll label it as 1. Now what else can we see? What is the number which we can always add to a divisible by x to keep the answer same? Suppose I have some number, let's say it's p. If I add some p is divisible by x, where p mod x equals to 0, then what I can do is p by x plus there's some number y which has to be added so that the answer remains same. Hmm. If we take some example that might be more clear, let's say 6 by 3 is equal to 2. Now, what is the number which you can always add to a divisible by x? We can add a 0 here, we can always add a 1 here, and we can add a 2 over here. So that I'll get answer 2 according to the normal division which is carried out in C++. But I cannot add 3 because we'll get a 3 over here, so the answer won't be same. So what I can add is 0, 1, and 2. So 0, 1 till x minus 1. This is what we can add to the number. Okay, this is the hint which we got. Now then the next thing is x, s is at least x into s. First let's see what does this hint mean to us. So if I want to keep this thing same, then what I need to do is I can add either ai plus 0 plus or 1 or x minus 1 to keep the thing same. Our aim is to make an array such that the sum of elements is s, and it follows this following property. If we look at the test cases, let me just make them side by side. If we see 1, 6, 3, and 100, n, k, b, and s. 100 is greater than equal to b into k. Okay, that's obeyed. But then also, why are we getting minus 1 as an answer? The question arises. First, we'll try solving why the answer does not exist, then we'll think about splitting them. Is there any lower bound on s and that it should be less than equal to something? What I need is sums to be 100 and b equals to k, and the answer also depends on n as well, no doubt. S is at least x into s. That's okay. Maximum remainder mod x is x minus 1. Okay. Then there's, I mean, that's it. We'll be utilizing those hints and trying it. Now, if we try replacing x with k, then sigma ai divided by k. What I can do is add a maximum of k minus 1 to this number. That's it. If I add a k minus 1 to this number, then also I'll be getting same answer. My answer won't change at all. So if I go on adding it, let's try creating an upper bound with this k minus 1. You know that sum is always remaining less than or equal to sigma ai plus k minus 1 divided by k for I equals to 1 to n. S by k is then equal to s plus n into k minus 1 divided by k. Hmm. So s is less than equal to s plus n into k minus 1. This is one thing, and it's greater than equal to b into k. This is one thing. I think this is what we needed to reduce. So therefore by this we get the inequality that b into k s s plus n into k minus 1. Okay. Now what do we have to do is, and now let's just verify the first test case. 16300 n k b and s. So b into k is 18 less than equal to 100 less than equal to 100 plus n into k minus 1. 1 into 5, it's 105. This is the condition which will be placed on 100 for this to happen. I don't think. Let's just write b less than equal to 1 minute. So now what we'll do is I'll just visualize all the things. First thing is that should be ultimately after doing all the, like, ultimately what we achieve is s is greater than equal to k into b. This is one thing. So suppose I created an array of, let's say, 5 elements. This will be k into b 0 0 0 0. This is the thing. Now what will be the maximum value of the sum of the array is I can add up to k minus 1 to this element, up to k minus 1 to this element, and up to k minus 1 to this element, and so on. So it's like n into k minus 1 s plus n into k minus 1. This is the maximum thing. Now sum will be greater than equal to k into b. I mean, this will be the minimum sum, okay, and the maximum sum is k into b plus n into k minus 1, and k into b is the minimum sum. This is the range for our s to exist. Otherwise, we'll print out a -1, and remaining printing of array can be done like I'll just print k into b. Now then I'll do s minus equal to k into b. Then what can I do is I'll just add plus minimum of k minus 1 comma s to this thing, and then we can proceed further on. That's it for this question. The thing was about getting the upper bound for this, which was tricky and time consuming. And then nkb and s, nkb s, cn nkb and s if s less than equal to k into b plus n into k minus 1, k into b plus n into k minus 1, and s is less than equal to, and s is greater than equal to k into b. Then only it will obey, otherwise I'll print a -1. So I got this intuition after viewing the solution. That's what he did in the solution actually. If you look at the C++ code, or else in the direct solution, he just said it. How did we have to do that? This is the maximum thing for the sum to exist, and we can just add to this overall. Then I'll create a vector int n comma 0 I comma n. First I'll set a0 equals to k into b, and then s minus equals to yeah, then s minus k into b. Now this remaining number we have to add to all the zeros and check them. Now what will I do is a of I plus or equals to minimum of, if this thing is greater than 0, then a of I plus or equal to minimum of k minus 1 comma s. I mean, yeah, what I'll do is s minus, I'll be subtracting, what did we have to subtract here actually? Yeah, k minus 1. Hmm. 1900 31 331, 3 plus 3 is 6, 6 plus 1 is 7, 38, well, minus 1 0. Mm, We'll try submitting it. It took me literally 1 hour to do this question, but still I didn't arrive at the intuition for getting the upper bound for this. Okay, it got accepted. Well, then that's it for today.